Hi everyone, this video is going to be on graphing our sine and cosine graphs. And these are just going to be the parent graphs, no transformations just yet. So these are our sine and our cosine graphs. Okay, so on these graphs, first we're going to start with some tables of values that we know using our unit circle, and then we're going to get it onto our graph. So I have my handy dandy little unit circle here. Of course I don't have all the values just because it's really small and I can't fit them, but we're going to use this to fill in our table of values for, we're going to start with sine x, or y equals sine x. So this is our first function we're going to graph, and with any graph we have our inputs and our outputs. So I'm going to make a table right here, and we're going to write what our y and our x values are. So our input and our output. Okay, so on our unit circle, we're looking for our sine values. So we're going to use some really easy ones. If our angle is 0, that's the same as 2 pi, that's just this right here. That point is positive 1, 0. Remember, the second value is sine, so when x is 0, or the angle, then our y value is 0, or sine. All right, let's do another really easy one. If I come up to 90 degrees, or pi over 2, that's the point 0, 1. Remember, the 1 is the sine value. So pi over 2, or 90 degrees, the sine value is 1. Then we come down to pi right here, that's 180 degrees. Our sine value is 0. So when x is pi, sine is 0. We have 3 pi over 2, that's 270 degrees. Our sine is negative 1. So when x is 3 pi over 2, output is negative 1. And then we come all the way back to our 2 pi, and that is again 0 for our output. Sine, or the y value here, is 0. Okay, so for our graph now, we are going to plot these points and see the shape that is created. So I'm going to start with 0, 0. And don't forget, our x values are angle measures. So our next one's pi over 2. So I'm going to go over pi over 2, up positive 1. Then I have over pi up 0. So we're back down to the x-axis. 3 pi over 2, negative 1. So now we're coming down here. And then over 2 pi, up or down 0. So now you can start to see as I connect these, and remember to make it really rounded. These graphs don't come to a point. We have now this shape that is our sine graph. Now this continues into the negative angles as well. So we're going to copy this shape, but as if it were continuing. So now if I were to come negative pi over 2, our y value would be negative 1. And then if we go over negative pi, we'd come back up to the x-axis, just like this. And that shape would continue forever in both directions. So that's our sine graph. Now our cosine graph looks just like this. It's just a shift, so it's just over a certain amount on the x-axis. So let's come down to our cosine graph now. We'll fill out that table, and we will see how that shape compares to the sine graph. So now we are working on our cosine. Okay, so again, I'm going to make a table for our values. And again, we're going to refer to our unit circle if we don't have these memorized. Okay, so for our cosine, we've got our x and y, our inputs and outputs. And again, we're going to take a look at this unit circle. All right, so for 0 degrees right here, our cosine would be 1. We went over 1. So 0 and 1. Pi over 2, our x value, or our cosine, is 0. So for 90 degrees, it's 0. Then we come down to pi. Our cosine is negative 1. So pi is negative 1. We come down to 270 degrees. It's 0. So 3 pi over 2 is 0. And then cosine of 2 pi, or 360 degrees, is going to be 1. So again, I'm just using the values on my unit circle, and those x values are the cosine right here. Okay, so just as we did above, we're going to graph these points now, and you'll see a similar shape for cosine. So our first point is 0, 1. So 0, 1. Cosine actually starts up on the y-axis. Over pi over 2 up to 0. So we're going to come down. Pi, -1. So you can see the curve now comes down to the negative values. 3 pi over 2, 0. We're back to the x-axis. And then 2 pi, and then up 1. All right. So if we were to continue that shape that we saw just above, it's the same curve, it's just shifted over. And again, this will continue over to the left side. So if I wanted negative pi over 2, we'd come back down to the x-axis. Negative pi, we'd come down to -1. Negative 3 pi over 2 would be back to the x-axis, and so on. It goes on forever. Okay, and so I'm just going to connect those just to show you that's going to continue down in both directions. And so this curve will continue in that shape and style forever in the negative and positive directions. So just a few pieces of information we have to remember about our cosine and sine graph when we start to do our transformations is that they have an amplitude and a period. Okay, so our amplitude, we'll start with that. Amplitude, this is going to be how, in simple terms, how tall or how low these curves go. Okay, so our parent graph has this middle line that these curves wrap around. For the parent graph, it's the x-axis. So if we want our amplitude, we just need to know how high this tallest point goes or how low the lowest point is. For our parent graph, it's always going to go up 1 and down 1. So our amplitude is 1. And then just so you guys can kind of see that, I'm going to just draw that in. This is our amplitude. All right, and then we have our period, and this is another value for our graphs, and this is a full rotation or a full cycle, basically. So you can almost think of it as a full rotation around a circle. If you start at the origin, or really whatever point, how far do you have to go until you've made an entire circle? So you can think about it, I have made the full top half of the circle all the way down here, that's the whole bottom of the circle, and when I hit this point right here at 2 pi, I have made a full, almost like a revolution, a full cycle. That is a full sine curve, okay? That's a full period. So it takes 2 pi, we can think of it as like a length, to go through one full period. These two values are the same for sine and cosine for their parent graphs. So you have to remember those for the parent graphs. And then also just a reminder, our input or our x values, those are the angles, right? So those are thetas. Your output or your y values, those are the ratios, those are the trig values. So I'm going to say those are ratios, those are the trig values. So again, your input, your x values on your x-axis, those are all angle measures. The y values are whatever the ratios are. Now we use the really easy ones, the -1, 1, 0, but of course there's also fractions that you could graph on there as well. All right, so in my next video, we will go over tangent graphs, and then we'll move on into our transformations of sine and cosine graphs. So we're going to stretch them, compress them, and shift them. Okay, thanks for watching, guys.